Alright, welcome back to the last concept under normal distribution. And we are going to be talking about combinations of different normal distribution curves into a new normal distribution curve. Okay, but basically, this concept essentially discusses the fact that, if you have a or different independent random variables. Okay, so let's say I have x, y, right? So these two, assuming they are independent of each other. Okay, so let's say x itself follows a normal distribution of let's say the mean value and the variance, and then y itself also follows its own mean and variance, right? So if these two are normally distributed, any linear combination of both of them will also be normally distributed as well, which means ax plus minus by will also follow a normal distribution as well. So I'm just going to write it in words over here. If A and B are normally distributed, right? If these two are normally distributed, any linear combination of both will also be linearly or will also be normally distributed. Will also be normally distributed. So they will have their own mean as well as their variance, right? So how do we actually calculate what is the mean and the variance of the linear combination over here? So this is where I want to introduce you a couple of concepts or a couple of formulas. Let's say I have ax plus b, okay? So this is scenario 1. So let's say scenario 1 is when I have just one variable, but then I scale it linearly, right? I include a gradient and then I include a sort of a y-intercept, right? A vertical shift. So this is scenario 1. And then there's also another kind of scenario, which is going to be under here. So scenario 2, whereby I have ax or plus minus by, where in this case, I actually include two different variables, right? And they are a linear combination of both of them. So for this case, the expectation of ax plus b, remember that the scalar multiple will not be affected, as in the scalar multiple will just be a scalar multiple, right? So in the end, you will just get ex plus b over here. In other words, the mean value, right? The mean value of this random variable will be a multiplied by the original mean value of ex, then you plus the b. Okay, now for the plus minus, right? So over here it will be plus minus. Now for the variance of ax plus minus b, it will be a square variance x. So note that the any constant will disappear, right? Any constant does not affect the variance, simply because variance measures the spread of the data from a center point, right? So if every single piece of data, including the center point, is being shifted up by b, if every single data shift up by b, then the distance is still the same, right? So let's say, imagine this is the distance, and then let's say I shift everything up by b units, right? So imagine here, I shift everything up by b units. The gap over here, this gap is still b units, right? So the b does not affect the variance. So in the end, it's still this over here. So in the end, what we get is that we'll get ax plus b, or rather ax plus minus b, will also be normally distributed with a mean value and a variance, right? But then this mean value over here will be calculated using this formula over here, and then this variance will be calculated using this formula over here, right? So that's that. Now, next for scenario 2, the expectation of this new combination of linear random variables over here plus b will just be aex plus minus bey. Okay, so the same concept, the scalar multiple comes out, and then you have your plus minus is still there. Now for the variance of ax plus minus by, it will just be a square variance x plus b square variance y. So note that for variance, regardless whether it's a plus or minus, here is always a plus. Okay, just take note that it will always become a plus. And the reason why it's always a plus is because variance is just a measure of how far the values are from the mean value, right? So what we are effectively doing is that we are taking the distance, the so-called the variance of a, the variance of x plus the variance of y, right? We will always add the total distances together. We will never subtract the total distances away from each other, because these two are two different data sets to begin with. So they will never minus each other, right? We are just adding on what is already existing. And another thing to note is that these two are independent as well, right? So these two, you can just imagine them as two independent sets of data that, do not affect each other, right? So just note that independence over here just means they do not affect each other, right? As simple as that. So in this bottom case over here, if let's say I have a linear combination of these two, they will both follow a normal distribution as well, because originally both x and y are normally distributed and they have a mean and a variance value. Now this mean value over here would be this value over here, and then this variance value over here would be whatever you see over here. Okay, so that is the whole idea behind it. Just to summarize what I've just said in the past 7 minutes. If you have two different normally distributed continuous random variables, if they are independent of each other, any linear combination of both of them will also be a normally distributed random variable. So when we combine these two, we get a new variable. And this new variable, since the original two variables are normally distributed, this new variable will also be normally distributed. It's just that now the parameters or the value of the parameters will change. So how do we exactly calculate the value of the parameters? That is where we have two scenarios. The first scenario is when you only have one random variable and then you just scale it, you multiply a value to it and then you add another value to it. Then this is exactly how we calculate the mean value and the variance, right? Whereas if it's scenario 2, where you actually have two different variables and then you combine them together, then this is where you will have this context over here, right? So this is how we actually calculate it. So that is just what I've gone through previously. Okay, so over here, I'm going to let you try out this question now. If you are feeling confident already, please go and attempt this question yourself and see whether you're able to derive the answer. If not, I'm going to be using this question over here to show you an example of how we actually applied these concepts previously into here, right? And after I go through this, then this is where the next few questions you will be trying them out yourselves because they are more or less about the same as this. So let's break down this question proper. We see that we have two different random variables. Over here, we have the marks of the boys. I'm just going to call this X. And we have the marks of the girls, which I'm going to call Y. So, of course, in the exam, we're going to define it. So we're going to let X be the examination mark of a randomly selected boy. Then let Y be the examination mark of a randomly selected girl. Okay, so we can see that X over here follows a normal distribution with a mean of 55 and a standard deviation of 11. So X follows a normal distribution with a mean of 55 and a standard deviation square, right? So because remember that this is variance, right? This is always variance. So we need to square it. But we know that standard deviation in this case is 11. And Y over here follows a normal distribution as well, whereby the mean is 58 and the standard deviation is 8. So 8 squared, right? Make sure you square it. So from here, we are told that if one boy and one girl are chosen at random from a complete list of candidates, calculate the probability that the sum of both marks is at most 100. So what they are saying is that from this pool over here, if I pick out one X value, and if I pull out one value from the Y pool, so a Y value, right, what is the probability that both X and Y is bigger, is at most 100? So that means smaller than or equals to 100, right? And in this case, you realize that we are trying to find the probability of this random variable, and this is a new random variable because it's a combination of both random variables previously, and now you can munch them together and now they are a new random variable. So since this is a new random variable that came from two random variables that were initially normally distributed, then that is where we need to calculate the new mean and new variance. So here, the expectation of X plus Y would be the expectation of X plus the expectation of Y. So it's just taking 55 plus 58 over here, and we get 100 and 113, right? 113 here. Then we also have the variance. So variance of X and Y is just the variance of X plus the variance of Y, right? We're just adding up the two together. So when we add up these two together, then that is where we end up with 11 square plus 8 square, right? That's why it's very important earlier on to square it so that now you don't add just 11 and 8 together, right? You actually add them, the variances together, and here you get 185. So now we know that we have a new random variable, which is normally distributed as well, with a expectation, which is the mean of 113, and the variance of 185. So now, in order to calculate part I, right, P X plus Y is lesser than or equals to 100, we can just simply key our GC and calculate the value. Okay, so here, second DISTR, again, this is your normal CDF, because we are just trying to find the area under the curve, right? our upper value is now 100, so 100, 100. Then the mean value is now 113, 113. And this over here is standard deviation, so you need to square the variance, right? And the variance that we got earlier on was 185. 185. You close it, you paste, enter, enter. 0.16959 dot 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 dot. So 0.16959 dot 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 dot. And I'm just going to return to here, and therefore from here I just 3SF it. 0.170 to 3SF, and that will be the final answer to that question over there. Okay, so that is the first answer to part I. Let's move on to double I over here. Okay, so for double I, the girl's mark exceeds the boy's mark. So in this case, that means that y value is bigger than x, right? So p, y is actually bigger than x. So this is the same as saying y minus x is bigger than 0, right? Which is also the same thing as saying 1 minus p, y minus x is lesser than 0, right? Because this from here to here, remember that our calculator cannot calculate the right tail on the normal CDF, but what it can do is that it can calculate the left tail. So we just need to find the complement, right? We take the complement so that this is something that we can key into our GC, right? But this is only applicable to normal CDF. But you know that for inverse norm, your calculator can do left tail, right tail, and center. But now you take a look at this, right? This over here is a brand new variable. So since this is a brand new variable again, we need to calculate the parameters. So the expectation of y minus x now is just the expectation of y minus the expectation of x, right? And the expectation of y, in this case, would be 58 minus 55. Oops, apologies. And 58 minus 55. And with 3. The variance of y minus x will be the variance of y plus the variance of x, right? Because remember, if it's minus, we will always add the variances together. And in the end, you have a value of, I think it's the same value as before, right? Yeah, it's the same value as before, of 185. Right, it's the same as the previous example over here. So therefore, from here, we get that y minus x is also normally distributed with a mean of 3 and a variance of 185. So now these are our new parameters. And from here, we can just key this into our GC to find out the answer to this question. So I'm just going to come back to my GC over here. I'm just going to click 1 minus normal CDF. Upper would be a value of 0, right? Because now, if you take a look at this, the upper value is 0 in this case, right? 0. And our mean value is now 3, and the variance is still 185. I'll paste, enter, I get a value of 0.58728. So 0.58728 dot 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 dot. And of course, I'm just going to 3SF it. 0.587 to 3SF. So that's the final answer to the next portion over here. Okay, so that's it. Now let's move on to the last portion of this question over here. Okay, last portion. The difference between the 2 marks is more than 20. So this one actually requires a little bit more nuance, right? Because when we say difference, it can be x is bigger than y or y is bigger than x, right? It can be either way. So how do we account for these cases? So this one over here, we can just simply say that modulus x minus y is bigger than 20. Because when we say modulus, it means the absolute value, right? So even in the instance that let's say x is more than y, for example, here is let's say 5, and then let's say here is like 20, right? Or okay, maybe I put 20, maybe I put like 50. So 5 minus 50 gives us negative 45. But when we modulus it, remember what modulus actually stands for. Modulus means absolute value of, right? The absolute distance or the absolute value of the number is 45. Right, we don't care about the negative sign anymore. So when we write it this way, it becomes a lot easier for us to solve this question, right? Because another alternative way to do this question would be to find both different scenarios, right? You take x minus y is bigger than 20 or y minus x is bigger than 20, right? Both is fine, right? And actually you are able to use both different curves that you have earlier on to solve this question if you use the second method, right? If you use this second method over here, then you can actually use this curve over here, the first distribution and the second distribution over here, right? You're able to use both for this case. So, feel free to use that, but I'm going to show you the modulus way, which is a lot more sophisticated, okay? And it's probably the way that your school would expect you to solve it also. But I'm not saying that this is wrong. Mathematically, it's not wrong, but this is the more sophisticated way. So how do we use the more sophisticated way to solve it? So from here, if you learn in your inequalities from J1, you know that modulus A bigger than B means that A is bigger than B or A is lesser than negative B, right? The distance from 0 has to be bigger than B. So the value is either bigger than the positive value or is lesser than the negative value. Because at the end of the day, we are just trying to find out what's the absolute distance. Because let's say if here is 0 right? And then here is b, right? And this distance here is b. This distance over here is also b as well, right? 90b. So we will want our value to fall either here or here, right? Because we want the absolute distance to be bigger than b. So this is the absolute distance, right? So that's the analogy behind it. So now we have px minus y is bigger than 20, or px minus y is lesser than negative 20. Now, since this is a normal CDF curve, we cannot have a right tail. And what that means for us is we need to find the left tail, right? So lesser than negative 20 plus x minus y is lesser than negative 20. Oops, here's 20, right? We are just flipping the tail. So now realize that x minus y over here is a brand new distribution once again, because earlier on what you have is you have x plus y, and over here you have y minus x, but you don't have x minus y. So this is a brand new distribution, and since this is a brand new distribution, we need to compute what the distribution is for this again. So I'm just going to erase this. So the expectation of x minus y will just be the expectation of x minus the expectation of y, right? Just minus away this two. I get 55 minus 58, I get negative 3, right? The variance of x minus y will still be the same, right? Variance x plus variance y, right? We never minus the variance from each other. So from here, we get the same value of 185. So in the end, x minus y is also another normally distributed variable with a mean of 93 and a variance of 185. That's that. So from here onwards, this is how we actually solve, right? All we need to do now is to use these parameters over here and key into our calculator this whole thing. So I'm just going to write the answer to this whole thing over here. Triple I, right? Apologies for the messiness, right? There's not much space over here. But that's what we're going to key now. So coming back to our calculator, I'm just going to quit and I'm just going to clear everything. 1 minus, then here, normal CDF, max value would be 20, and the mean is negative 3, right? I minus already. Then I plus. Normal CDF goes up to negative 20, and then I go all the way here, I paste, I enter, I get 0.15109, right? So 0.15109 dot 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 dot, and then you just 3SF it. So it's 0.15123SF. And that's the final answer to this question over here. Okay, so in the next video, right, subsequent videos, we will be going through more questions, around this concept and the whole idea of normal distribution. So if you've got any other questions for this example question over here, do leave in the comments below or reach out through WhatsApp. If not, we are going to be running through very specifically exam type of questions for normal distribution. Let's start with the next question over here. And again, feel free to pause this video to tackle this question and come back when you're ready. Okay, if not, I will begin doing this question right now. So the thing is that this question already defined for us what's the random variables. We have a C and D, right? And we are told that C and D are independent of each other. So just as a pro tip, right, in exams, sometimes they may throw a 1-mark question, which is asking you what is a assumption made that must be made to this question, right? Or something about an assumption being made. So questions can test this, and all you need to write is that the random variables are independent of each other. Okay, so this is the can be a question as well. Can be a question. Okay, and it's a free 1 mark, so please get that 1 mark. Okay, if not, but still we need to define the C and the D over here. So I'll be let C be the mass of a randomly selected chick. Let D be the mass of a randomly selected duckling. Okay, we need to define the two random variables because of this very important word, randomly. So as a formality sake, right, I'll just always write this in the question. So we know that C is normally distributed with a mean of 99, standard deviation of 14 squared, and D is normally distributed with a mean of 113 and a standard deviation of 16 squared. So now we want to find the probability that twice the mass of a chick. So that means we have one chick, twice the mass of that chick. So it's 2C, so it's a big chick. Okay, and then now we have mass of a duckling. So we have D over here. So probability that 2C is bigger than D. So for part I, they actually want us to find 2C is bigger than D, right? And of course, we can write this as 2C minus D is bigger than 0. And since this is a normal CDF function in your calculator, you cannot key this in directly, right? So what you need to do is you need to 1 minus P, 2C minus D lesser than 0, right? You need to take the complement of it. So I'm just going to write it here. Hashtag take the complement. Very important. So we realize that now we have a new variable called 2C minus D. And for this, we need to figure out what are the parameters now. But since C and D are independent of each other, and C originally follows a normal distribution, and D originally follows a normal distribution, we can safely say that 2C minus D also follows a normal distribution. But what are the parameters over here? That is the thing that we need to calculate now. So the mean value would be the expectation of 2C minus D, which we can split to become 2EC minus ED. So this will be 2 times 99 minus 113, right? So 2 times 99 minus 113, and that will give me a final value of 85. So here would be 85. And next, the variance square, right? Variance would be variance of 2C minus D, and we become 2 square variance of C plus, right? Because remember what I said earlier, variance is always you plus, you will never minus variance from each other, because variance at the core of it is trying to calculate the spread. So what we want to do is we want to take the total spread of C plus the total spread of D, and therefore here will be variance of D. So 4 times 14 square plus 16 square. And what we should be getting is this final value over here of 1040. So here is 1040 in short. So that's it. And now we want to calculate this value over here, right? So from this whole line over here, we can simply just calculate the value using this 1040, right? So fairly straightforward for that. Now we just got to go for GC and calculate this whole value over here. So let me pull up the GC. Okay, good. Now again, so what we're going to do is that we're going to key 1 minus first. So we have 1 minus, I'm just going to shift it down so you can see. Okay, second, DISTR, normal CDF. Upper limit now would be a value of 0, right? This is the upper limit. So this is 0, oops, 0. And then the mean value will be 85. And then our standard deviation will be the variance square rooted. So here we put 1, 0, 4, 0. Right, then I delete this, I close it, I go down, paste, enter. 0.995. Oh wait, apologies, I just realized the question said at least 20 grams. Apologies, so sorry for that. So that means here should be 20, make more sense. Lesser than 20. So all I need to do here is to change my upper limit to 20. So here would be 20 instead. Okay, now I'll just redo this whole thing. Okay, bear with me. 1 minus DISTR, enter, upper will be 20 instead, right? And I'll go all the way down, paste, enter, 0. Yeah, so this is the correct value over here. So I should be getting a value of 0.97807 dot dot dot, right? Which will be 0.97823 SF as the final answer to this portion over here. Okay, so that's it for the first part. Now I'm going to move on to the next part. Feel free to pause this video now if you need. Okay, moving on to the next part. If the probability of the total mass of 2 randomly chosen chicks, so now we have 2 chicks, that means C1 plus C2, okay, different from 2C, as I mentioned earlier, exceeding weight is 0.9. So now we know the probability. So when we set up the equation, it says that the probability of 2 chicks, so C1 plus C2, exceeding K, so exceeding K grams, equals to a value of 0.9, right? So now we need to find what's K. But again, 2 things. First is our calculator cannot calculate right tail, right? We need to do the left tail because normal CDF. So therefore, this will be P C1 plus C2 lesser than K equals to 1 minus 0.9, right? So P bracket C1 plus C2 lesser than K equals to 0.1 over here, right? And then this 0.1, it checks out because now it's on the left tail. So next, we need to find out what is the distribution parameters for this. But we know that it's normally distributed because both of them come from C, and C originally is normally distributed. So again, we need to calculate these 2 parameters. So the mean will be the expectation of C1 plus C2, which is the expectation of C1 plus the expectation of C, and this would be 99 plus 99, and we will eventually get a value here of 198, right? 198 over there. Then the variance will be the variance of C1 plus C2, which is just the variance of C1 plus the variance of C2, and it's just taking the variance, which is 14 square plus 14 square here. So I will get 392. So we input these values here, and now we are able to calculate what is K. So now, since we already know this and we want to find this is very clearly inverse norm, right, on your calculator. So you can just say from GC, the K value is something, right? How do we calculate this K value? is by using the inverse norm function. So inverse norm, because we know the area under the curve is 0.1 and we know the parameters, right? The parameters are 198 and root 392 and it's left tail. Actually, yeah, don't need to change that at the start, but I'll just change because out of habit. Okay, paste, enter, I get 172.626 dot dot dot. So it's 172.62 dot 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 dot, right? And this would be 172.6225 SF. Now, if I were to put it at 173, right, to 3SF, then that would be wrong, right? Because there's a very big difference between 172.62 and 173. So in this case, I think 5SF will be more, more appropriate lah in this case, right? Yeah. So essentially how this looks like is we have a normal distribution curve like that. The center here is 198, here is 172.62, and then this whole area over here is 0.1, right? That's what's happening. So if I put 173, then the accuracy might be a little bit off, right? So I think 172.62 will be more appropriate for this context. Okay, so that will be it for double I. Now, triple I, probability that the average masses of 2 randomly chosen chicks and 3 randomly chosen ducklings is less than 100 grams. So again, the keyword here is average, and average means need to divide by the total number of animals. So we have 5 animals in this case, so we need to divide by 5. So for triple I, what I'll do is before I do triple I, let me clear up the space here. I'll just put it here. Okay, triple I, I'll just put it here. Okay, so double I answers are here if you need. If not, I will go through triple I right now. So I'm first gonna define. I'm just gonna let A be the average mass of all. Right. So I know A is 2 randomly chosen chicks, so C1 plus C2, and then 3 randomly chosen ducklings, so it's D1 plus D2 plus D3. Then after that, I divide by 5, right? Because it's the average. So obviously A will follow a normal distribution as well. And what we need to do is that we need to calculate the parameters. So expectation of A will be 1 over 5 times the expectation of C1, expectation of C2, and then expectation of D1, expectation of D2, expectation of D3, right? So in the end, we just need to input all these values individually. So that means it'll be 1 over 5 times 99 times 2, or you can just put 99 plus 99 if you want to really follow the same way of presenting. 113, 113, 113, right? So you just add all of them together. 3 plus 113 divided by 5. So I get 107.4 over here. I'm just going to segregate the question. Then again, here, what I need to do now is to find the variance, right? Because now I know the expectation, now I find the variance. So the variance of A would be 1 over 5 squared. Variance of C1, variance of C2, variance of D1, variance of D2, variance of D3. So over here, in the end, I will get 1 over 25 times 14 square plus 14 square plus 16 square plus 16 square plus 16 square. Oh, I'm so sorry you weren't able to see that. Okay, then from here, I will just key this whole thing into my calculator. 14 square plus 14 square plus 16 square times 3 in my calculator, and I'll get a value of 46.4. So what this means for us is this value over here is 107.4, and this value over here is 46.4. Okay, so with that, we can now find the value, because now in triple I, you just want to find the probability of A being lesser than 100. So this is something that we can directly key into our GC again, right? So we just want to click inverse norm, normal CDF. Upper limit is 100, then the mean is 107.4, and then the standard deviation is root 46.4. So root 46.4, paste, enter. 0.1386 dot 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 is 0.1386 dot dot dot, which is 0.14023 SF, right? And that will be the final answer to this question over here. So I apologize for my working being all over the place, but that will be all for this portion over here. Okay, if you have any other questions, leave it in the comments below, or reach out to me through WhatsApp. Okay, so let's move on to the last question over here. And again, feel free to pause this video to attempt this question, and when you're ready, resume, and let's begin this question. So over here, we have the mass of a salmon fish, and once again, this is our random variable, so we'll just call this x. And we have the mass of a tuna fish, So this is our random variable and we'll just call this y. Now they have two distributions, 2, 0.25 and 3, 0.64. So I'm just going to define it first, and we always have to define the random variables even though it might be very obvious what it is already. Right, so we'll let x be the mass of a randomly selected salmon fish. We will let y be the mass of a randomly selected tuna fish. So it is given by the question that x follows a normal distribution, right, of a value of 2, 0.25. And for y, it follows a normal distribution of 3, 0.64. So for the first part of the question, it's actually asking us to find the probability that the mass of 4 salmon fishes, so these are all separate salmon fishes, right? So I have 4 salmon fishes, so that would be x1 plus x2 plus x3 plus x4, right? 4 separate salmon fishes, and is more than 3 times the mass of a tuna fish. So the probability that this whole thing is bigger than 3 times of one fish. So this will be 3 times of one fish. So note that these two are very, very different, right? Even though mathematically, we can technically say that this is 4 times x, but logically it doesn't make sense, right? We have 4 different salmon fishes and 1 tuna fish, and we're taking 3 times the mass of that tuna fish. So that's the key difference over there. Okay, so we want to find out what is this. We'll bring the 3y to the left hand side. And again, normal CDF, you cannot calculate your right tail. So what you will do instead is you will calculate the complement and take the left tail instead. x3 x4 minus 3y is lesser than 0. So again, this now forms its own distribution, right? And we are just going to let a be x1 plus x2 plus x3 plus x4 minus 3y. So since it's formed its own distribution, we need to find out what its parameters, right? What is the mean as well as the standard deviations, which will bring us to what variance is. So how do we find the mean? That would be the expectation of A. And in this case, we will have the expectation of x. So 2 plus 2 plus 2 plus 2 minus 3 of y, right? So this will give us a value of 8 minus 9, which gives us negative 1. And for our variance, which is this, right, we have variance of A. So in this case, we'll take the variance of A plus the variance the variance of all the x values. And then in this case, it's a minus, but because it's a minus, it'll become a plus, right? Because we're talking about variance, and variance will always add. Now over here, there's a coefficient of 3. So therefore now it becomes 3 squared. And then the variance of y is 0.64. So here's 0.64, right? So all in all, I have 0.25 times 4 plus 9 times 0.64. And I get a value of 6.76. So here I get negative 1, 6.76 over here. So therefore, I can use this whole distribution to calculate this value over here. And all I need to do now is to go to my online GC. Okay, so what we want to do right now is to actually calculate this, right, using these parameters. So we will come back to our GC, or rather we'll click 1 minus second DRSDR, normal CDF first. Oops. Now you can see that our upper limit has a value of 0 here, right? So upper limit, once again, here is 0. Then the mean value in this context would be negative 1. So I'm just going to come back here and I'll key negative 1. And the standard deviation is square root of variance. So I'm just going to square root 6.76. Close it, paste, enter, and I get a value of 0.350261 ... Right, so I'm just going to come here and key 0.356, 0.261 ... then 23SF, and that's the final answer to the first part over here. Okay, so I'm just going to strike it off. So that's it for the first part. Let's move on to the second part. And for the second part over here, we are asked to find the probability of 4 salmon fishes is more than that of 3 randomly chosen tuna fishes. So the context is a little bit different, even though the wordings might sound roughly the same, right? We still have four salmon fishes. It's just that now, instead of one tuna fish and then we multiply by 3, we have 3 separate tuna fishes. So it's slightly different now. I'm going to bring it to the bottom. Yeah. So now we want to find x1, x2, x3, x4, right? 4 salmon fishes is more than 3, so it's more than 3 randomly selected tuna fishes, right? This is what we are trying to find. So again, we are going to bring everything to the left hand side of the inequality first. Minus y2 minus y3 is bigger than 0. And then we are going to take the inverse of it, right? The complement of it. So 1 minus p x1, x2, x3, x4, y1, y2, y3 lesser than 0, right? Because this is something that we can key into our GC. So again, you realize that now we have a brand new continuous random variable. So with this continuous random variable, we need to define the parameters. So I'm just going to let A or let B be x1 plus x2 plus x3 plus x4 minus y1 minus y2 minus y3, right? And once I do this, I will need to find the distribution parameters for B. So what's the mean value of B? This will be the expectation of B, right? And you can see for this, it's just, you will just add up all the expectation of X and all the expectation of Y, right? So expectation of X is 2 and Y is 3. So it's 2 plus 2 plus 2 plus 2 minus 3 minus 3 minus 3. So in the end, I get 8 minus 9, which still gives me -1, right? Now for the variance, that is something a little bit different, right? Now the variance, it will be the variance of B. So again, all the minus will now become plus, and therefore it will just be 0.25, 0.64, right? So what we have is 0.25 plus 0.25 plus 0.25 plus 0.25 plus, right? Because variance, you always plus. So 0.64 plus 0.64 plus 0.64. So I add everything up together, I end up with 2.92. So in the end, my distribution looks like this. And therefore, I can use this to calculate this value above. Right, so again, I'm going to go back to my GC now. Here, I'm going to click 1 minus second DISTR normal CDF, and then my upper limit will be 0. My mean is -1, but now my variance is 2.92, so my standard deviation will change. Right now it's 2.92, paste. So in the end, I get a value of 0.27920, right? Which gives me 0.27923SF as the final answer to this question over here. Okay, so very similar to the first one. Just take note that now instead of multiplying by 3, we have 3 separate fishes. That's why we don't times them together. Okay, so with that brings me on to the third part. State an assumption needed for a calculation for both parts to be valid. So we mentioned about this earlier on in the earlier questions and even the concept video, is that in order for us to group have linear combinations of independent variables, right? So let's say I have 1 here and something here, right? In order for us to combine these two into something that it looks something like this, and to say that they follow a normal distribution themselves, right? This can only happen if X and Y, the two random variables, are independent of each other, right? We can only assume this is the case when they are independent of each other, because if they are not independent of each other, then that is where if you think about it, if they are not independent of each other, that means they affect each other, right? So when they affect each other, we can no longer say with confidence that the final distribution is yet another normal distribution, because a normal distribution curve is one that is symmetrical about the mean. And if these two values actually affect each other, we can't say for sure whether the tip of the curve will deviate from the mean value, right? It might be skewed already. So to contextualize in this question, right, we will say that the assumption made is that the mass of the tuna fish is independent, mass of the selected tuna fish is independent of the mass of the randomly, okay, I'm just going to randomly selected, okay, so randomly selected fish is independent of the mass of the randomly selected salmon fish. Okay, we need to talk about it this way. So just a pro tip right, to include the word randomly selected, because again, everything over here is up to chance, right? It's all up to probability. So we, include these kind of keywords to signal to the examiner that, we know our stuff, right? And then that's about it. So that will be the third part. Lastly, they say, given that 75% of the time, so 75% of the time means a probability of 0.75, the total mass of n randomly chosen tuna fish is less than 50 kg. Find the value of. So the total mass of n randomly chosen tuna fishes. So why lah? So how do we actually tackle this question? Let's first translate that sentence into a mathematical equation. So I'm just going to write it over here, okay, for IB. So we are saying that the probability of n tuna fishes, so I have y1, y2, y3, y4 plus dot 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 plus yn, right? Over here I have n tuna fishes. So the probability of n tuna fishes having a mass less than 50 kg, right? So having a mass less than 50 kg is 0.75. Now the question is, what is n? So this itself forms its own distribution as well, right? I'm just going to let C be y1 plus y2 plus y3 plus dot 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 plus yn. So C itself forms its own distribution where it has its own distribution parameters as well. So the mean value of C, which would be the expectation of C, would be the expectation of y1 plus the expectation of y2 plus the expectation of y3, and then you carry on all the way until the expectation of yn. So in the end, you have n number of expectation of y, right? And that means that would be n times 3, right? N times 3, which gives you 3n. So here is 3n. And then you have your variance, or C, which is just your variance of y1. Then you just repeat, right? Variance of y2 plus variance of y3. And then you repeat all the way until you get the variance of yn. So in the end, you have n times the number of variance. And the variance in this context would be 0.64. So you have 0.64n. So these are your parameters so far, right? So how do we actually tackle this question over here? It's very, very interesting because you look now, you have this unknown variable, right? This is our unknown variable. And this unknown variable is chucked inside this whole entire equation over here, whereby it's equals to 0.75. So first thing is that we cannot inverse norm this function here, simply because we don't know what is the value of n, right? So we cannot key a definite value for our mean, and same for our variance. So this is actually the trick. It's all about graphs. Let me show you. So I'm just going to come back to here, right? I'm going to go to a graph. Now on this graph over here, I'm going to key second DRSDR, I'm going to key this. And then my upper value is 50, right? So this is 50. And then my mean value over here has a value of 3n, right? So I'm just going to put 3x over here. And then the standard deviation would be 0.64n, right? So I'm just going to square root 0.64x over here, and I'll close it and I'll paste. So you see that what I've done is that I have just created a function whereby the output of this whole function over here is y1, and this output varies with different values of x. So now I want to find out what is the value of x over here that will give me an output of 0.75. And the way that we can do that is to find the intersection between these two graphs, right? Because when we have an intersection between this graph, whereby the x varies and therefore the y value varies, and with a value of y which is 0.75, the intersection between these two graphs will be the value that we want to find, right? That will give us the value of x. So you see, if I graph it, they will intersect at some place, right? And let's say I zoom in, or rather I zoom out. Let me just zoom out first. I zoom out. So, or maybe I zoom in. Yeah, I'll just zoom in to perhaps say here. Yeah, enter. Okay, and then maybe from here, let me just trace and find out where they intersect. So let me go down to number 5. Then let's say I click here, and then maybe I just go all the way until the very end over here and here, right? boom, they intersect here. So you can see that over here, when y is 0.75, x is 15.948, right? So I'm just going to key here. So from the GC, when y is 0.75, or rather when n is 15.9483 dot 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 dot. Oops, apologies. Right? When this is the case, then the probability of C being lesser than 50 will be 0.75. Oops. So therefore, the value of n would be 16 to the nearest whole number, because we cannot have a decimal of a fish, right? And therefore, this is the answer to this question over here. So you can see that it's very, very interesting. You know, how you can use graphing techniques to actually solve a probability question, right? So this just goes to prove that, once again, H2 math is not so straightforward. It's not so by the book kind of method always. Sometimes you need to be a little bit more creative, and you need to spot patterns. For example, this question where, I have an unknown variable, right? And this unknown variable is part of a function that gives me an output. So if I want to find out what's the value of this, and I know the output that I want to achieve, I can plot it into my GC and then calculate what's the input that actually gives me this output by just plotting two graphs and finding the point of intersection. Okay, so yeah, that's just one example over here. With that said, we have come to the end of this video over here. Any questions, let me know in the comments, or reach out to me through WhatsApp, and I'll see you in the next video.